Okay, so welcome. This is the engineering modeling and design workshop. Here we plan to teach you a bit of how the project works and how you can take something from a simple sketch to an actual project. So with today's presentation, the outline of the topic will go step by step of how we plan to grab something like an idea to success, how we conceptualize the idea, how we a method of how we can draw it, how we can convey that idea, how to have a sketch to 3D, the programs we can use for that, and then we have a small activity plan for all of you guys. But I think before we do the activity, I'm gonna explain the space protocols first, so we have the entire rest of the time to do the activity. So, okay, no, wait, go back. So before we start, this is a really simple thing. I want you with the paper I gave you and the materials. I just want you to see them and maybe draw a small car. How do you expect you can build a small car with that? So just grab a pencil. It has to be something really simple. If you don't know how to draw, just draw a square, add wheels.
I have to draw a car.
Yeah, with the materials that we have provided. So, really important material, I forgot to give out. It's gonna be made with propellers.
Oh,
Yes, you found that.
Artist. Yeah, to give everybody an equal chance. Okay.
Okay. Here's another one if somebody breaks it.
Okay.
Yeah. You get up first. For my own. It's a good point.
Want to spell it in rough sketch?
You think? No. For day? Wow.
But do they not touch the ground?
I mean, technically, it depends how you do it. That's why you have to design it out. Technically, you can make, because it's called. Oh, you can make an elevation.
Elevation, yeah,
Like a base.
yeah,
In fact,
with the wooden sticks.
Yeah.
It's not the propeller, maybe not like upward, but like on an angle.
So when they can do that. Everything they do will affect the final model.
They have to place consequence of it.
Okay, so meanwhile, finish the drawing you're doing or planning. I want to give you some steps like probably follow or you can follow if you're still stuck. But first, we have to conceptualize the idea. Let's say we have the materials, you have to think about, okay, I have this, and how do I apply this into a car? And really probably you're gonna imagine an image, a model in your mind. So you have to write it down somewhere, even though it's really bad, really like a sketch, a really simple sketch. It's a really good to have it written down. That's basically a conceptualization. Then what you do after that is you research. And then let's say with this example, you say, okay, based on the concept like this and the materials I have, how can I investigate all the little things to get the best out of the materials and get the best of them?
Yeah, how to be more resourceful with what you got, basically.
Yes, then we go directly into that design. Now, based on your previous research, concept, and image, you can make a proper design. It doesn't have to be in real life. It can just be a model or a proper image that has, let's say, the measurement, the dimensions, the weight of what you're actually gonna build. The design is basically like a blueprint of your idea. Then after all that, we just create. Because
Prototyping.
yeah, the prototype basically. Because at the end, you have the blueprint, so what's stopping you if you have the materials and everything? So this is where the project becomes a reality. So, okay, with conceptualization, what you have to do is first you identify the problem. What's your problem here? I came out of nowhere and told you to build a car. And probably most of you have no idea how to do it. So you start thinking, you start identifying a problem, saying, okay, with the things I have, how do I build a car? Then you start brainstorming solutions. Basically, you start thinking, okay, I can put the propeller on the front, on the back. I can make the wheels like this or that. And you start thinking and processing all the possible solutions towards the goal to solve the problem. Then you define the objective. Okay, so here you want to build a car, really simple objective. So with all the solution and the problem in mind, you say, okay, this is the best way I can make a fast car with the things I have. Then you gather all the data, let's say all the materials you have, all the sizes, the time, the resources to make it. And then you create the visual representation, which is basically a drawing of what you're gonna do. But in this case, it's gonna be more simpler as a visual model. You can do like 3D, being simple. I don't know. Think
Okay. So. Okay, so, once you have a sketch, maybe you want to draw it in 3D. So what you do is, first have a clear idea of what you want to do, and then you can pick up a perspective of how you want to, draw your design. It could be 2D or 3D, even 2.5D, which is like in between 2 and 3D. And then, we can start, thinking about how you can erase your, primary components. And then you can start drawing 2D, basic 2D and or 3D shapes to fulfill your needs. Because what you want to do is start with simple complexity, and then you can add on components into your drawing. And then maybe you can start thinking about the dimensions of um, your drawing and your concept, and that will allow you to contextualize your drawing and make sure that it's going to be logical and you're going to be able to approach it. And with that, you can start thinking about the sectors, maybe drawing different perspectives of your design, and also thinking, yeah, I need a marker. Let me go get a marker.
Here's one.
Okay. So, with this point, what I wanted to explain is that if you want to draw this in 3D in a computer-aided design software, you gotta think how you can reduce complexity. So for example, you wanna make a tube. What you start is with the circle, and with the circle you can just extrude it, which means that you just give it elevation and depth. Yeah, because otherwise, if you start with like a foil, like a rectangle, just the fact that having to roll it up is just much more complicated to do in this program. Okay, so with the orthographic drawings, there's an approach to sketching your ideas into 3D or 2D. What you gotta think is the materials that you need and may use, and then have the measurements such as the dimension, size, and weight, and the optionality, such as checking the viability, the cost, and the returns of your concept.
Okay, so here I added an example. Well, this is more of a conceptualization than a orthographic drawing. But this is an old model I made like a year, 2 years ago of a lunar rover. That's the one we are planning to do, really similar to this one, just a lot more advanced. It's this drawing is so old, but with this, you can maybe get an example of what you have to draw, what maybe you can see ahead of a professional drawing in the engineering field. So here you can see the model from the top, it's 2D, but over there you can see it on the side. And basically what it does is states the measurements, the components it has, basically all the dimensions and most of the important things that when you show the model before you build it, this is what they're gonna look at to know what you're actually gonna build.
Okay, so if you want to work with computer aided design with CAD, there's quite a selection of programs that you can use. I think the easiest one to start with is either Tinkercad or Onshape. You've probably heard of Tinkercad before, and it's a free to use cloud-based service that, well, it's not only easy to use because they reduce complexity by using simpler functions, but they also have like public libraries of resources that you can grab and access for free, or maybe if you have the money, you can buy some. And there's also the simple UI they have, and it's owned by CAD. And there's also Fusion 360 and AutoCAD, which is more of a general purpose software, but it's a little bit more complex. It has a medium learning curve, and you can use it to make 2D technical drawings, similar to like what Manfred has done and making schematics. And now talking about the more complex program, SolidWorks is more industrial level, and it's much more complex than the Fusion 360 and AutoCAD, and it's used for mechanical and assembly. And they support things such as the computer aided manufacturing, computer aided engineering, and computer aided design compared to the other options. And just to get the license for this one is higher compared to the other options. The one that I personally used before in the past is Onshape, which is similar to Tinkercad. It's also a cloud-based service, and they allow also live collaboration and mechanical integration. The advantage of the online services is that if you have like a slow computer or you can't download some of the other heavy programs, you can just use the online version, and that will allow you to get to work with 3D design software. Additionally, I think if you start with the simpler programs, they'll allow you to build some familiarity with the other services, complex services, and it will allow you to progress in the learning curve, basically. Yeah, so here's a diagram of like the different services that exist. And I mean, not all of them have all the features that could be implemented. Some programs are more dedicated towards manufacturing or engineering or even designing. So I think that's something that you might want to look into if you want to get into a specific project. So it'll be more beneficial to you than another one that is for a different purpose, such as modeling.
Okay, so before we go into the activity, I'm gonna go into the space mission protocol because it's an important thing to know. As here in Red Planet, we're gonna work with the space mission protocol. So basically, no, go back. Some of the applications of all these modelings and stuff, like the visual representation, we can use it in things as simple as prototyping, which is basically just to test complexities, more immersive and real thing and more understandable. And it's basically for practical applications, as it's the real thing that you can go in, interact, feel, you have the materials, the weight, the size, and all those details that somebody might be interested in seeing when you're presenting an idea. We can use it to 3D print, which is, well, really similar. I'm guessing all of you know what 3D printing is, which is just really, really quick to print. It's cheap. The materials will be different from the actual plan, but you can see the size and how it's gonna work with the interactions of the pieces and all that, and it's very on demand. As 3D printing, you can set it to print and it's gonna take a couple of hours depending on what you're printing. And it's something really quick, fast. It's for smaller scale projects. It really depends.
And here in the university, I think we have like we have
Yeah, we have,
two different types of
yeah, we
printers.
have two 3D resin printers and two 3D printers, normal ones, that we can use anytime we want. You just have to tell us and well, you see, we'll go into the lab more once we start working on the projects. So look forward to it. And then, well, the assets, Danny knows a bit more about.
Yeah. So yeah, they're very multifaceted. You can use it for animation, 3D printing, video and video games. And in my case, I also wanted to mention for the applications, I was trying to learn MATLAB. I borrowed some books, loaned some books from the library here, and I was trying to read how to do MATLAB and use it for simulations and other math projects I had in mind. And for the assets, yeah, they have a lot of applicability and they're very on demand with the market. You can, if you become very good at modeling, you can sell your models online or even send them for free. And they're also good for simulation.
Okay, so now with the space mission protocols. So this is basically how NASA works, how in the space industry, it's usually managed to start a simple idea to a big scale space mission. So first of all, they go into the research phase, then the design and development phase, and the manufacturing phase. Here they might sound as simple things like, okay, 1, 2, 3, and then we're done. But actually, each step has its own process into it. So in the research phase, it's basically just the abstract, which is a summary of what you plan to do in the mission. Then you go into the product functional architecture. What's that? It's basically the technical specifications of, okay, we plan to do this and we're gonna do it like this. It's basically how you're gonna approach the big idea you have in the field. Then the early feasibility reports in the space industry, since there's not much known, we tend to relate back to past missions, past investigations done. So in the early feasibility reports, instead of, let's say, we go here to a project of science on Earth, and we say, okay, because this happened on Earth, it's gonna happen on space. No, we actually see the past missions and say, okay, the closest we have of information of what's gonna happen, let's say the results is if we base ourselves on the past mission on 2011, I don't know, let's say a stem cell mission. We can see, okay, the stem cell behavior was like this, and this. So based on this mission, we can,
Approach it similarly.
yeah, to see and get similar results. That's what we want. And the early product concept, which is basically what we're gonna sell. Because at the end of the day, nobody's gonna send something to space if you don't have money and you're not gonna make money out of the project, even though maybe if you have a millionaire friend, you can let us know and maybe we can send something. But basically, the concept is what you're gonna sell. You want to know what specifically you're gonna do and say, okay, this is what we propose, this is what we have, this is how much money it's gonna cost, and how much money we're gonna make out of the project. Because at the end of the day, everything is an investment. Then we go into the design and development phase, which is basically when you start the engineering drawings. Basically, you start the interface documents, which is all the information about the research, what you're gonna present, and all the progressive information and data you get. Then we get the final risk evaluation, because at the end of the day, in the space industry, everything has a risk. You don't really know what's gonna happen. So you want to know what are the risks of everything happening to your project once you send it to space. Let's say your project has a 20% chance of exploding, I don't know. And it has a 10% chance of malfunctioning thanks to electrical components. So you really wanna know that before you actually send it, to know every possible outcome for the mission. And then you do the final documentation, which is basically a really, really formal document easy style, more technical, which is gonna present the entire mission, saying, okay, this is step one, and this is the last step, and you're gonna see everything in a single document. Then we go into the manufacturing step. Here is more of a legal theme because you have to get a lot of test approval from NASA, the space industry, from where you're launching in. You have to get certification, so you know you're not launching, let's say, a missile or something like that that's gonna hurt humanity. So basically, that's the accepted requirements in a compliance checklist. You just see that you have everything, ensure that the mission is safe, it's not gonna blow up the world or something like that. Then you have the deployment, which is the actual launch of the mission, for it to go, see how it's gonna perform, all the data. And well, basically, then you get the test results, which is all the details you get at the end of the mission. And there you can ensure, okay, what's this, it's worth it? Did it go as we expected? Yes or not? But this is basically a really summarized version. I can really go into detail about it because I'm not even supposed to talk about it. But here is like the main idea of how we're gonna work in Red Planet with the projects. I know it's a bit more complicated, but it's a lot more fun knowing that we're working the same as NASA, and it's really, really organized. So it's a really good way to work. And so, yes, now we go into the activity. Before we start actually building something, the idea is based on your drawing, try to build it in 3D with the materials you have. Really simple, I know, but give it a try. You will see that it's not as easy as it sounds.